This is the Earth Science Classroom. Welcome back to the channel. This video is all about igneous rocks, the characteristics, formation, and definition of this rock type. By definition, igneous rocks are the result of cooling magma or cooling lava either under the surface, within the crust or lithosphere, or as per lava on the surface, and it cools and forms a rock from liquid to rock. So the definition is it's a rock formed from liquid or molten lava or magma from either a cooling situation under the Earth's surface in the crust or through volcanic activity on the surface. Now, this rock is the first type of rock formed in the rock cycle, and as all rocks are derived from magma or lava, igneous rocks are the first type, and they form the basis and foundation for our continental crust and also our ocean floor geology. Igneous rocks are either formed underground or on the surface through volcanic activity. So if they are formed underground through cooling magma very slowly, they are called intrusive igneous rocks or plutonic. If they're formed through volcanic activity, as seen by this amazing eruption, then they are called extrusive or volcanic igneous rocks. So igneous rocks that are formed underground, which are intrusive, have a distinctive characteristic based on how fast they cool down and the mixing of the magma, the assimilation of the magma, and how it erupts, if it erupts, and where it erupts will dictate the chemistry of the minerals, and the composition of the magma will dictate the rock that is created, either be granite or diorite or andesite or pyrrhotite, depends on the location and depth of the forming or cooling magma into rock. So for extrusive or volcanic igneous rocks, the location of volcanoes, the location of subduction zones, plate tectonics, and how the crust is broken into plates and is slowly moving over a long period of time based on convection currents in the asthenosphere, is basically the foundation of our understanding of how the surface changes over time, how continents come and go, oceans come and go, the Wilson cycle, and we can also dictate and show how the different geology and mineral makeup of these rocks dictate where they form, how old they are, and we can basically backtrack on these age of rocks on the location and the formation of when it actually happened, so we can look back into the Earth's history and see what different environments were like in different areas of the world. So igneous rocks play a huge part in this type of science. So scientists have the ability to study firsthand the formation of extrusive igneous rocks through volcanic activity, but you also have the amazing large samples of intrusive igneous rocks through uplift and tectonic activity, whereby some mountain ranges, or the core of most mountain ranges, is going to be intrusive igneous rock through the cooling of magma, creating these large plutonic features like batholiths and stocks that are pushed to the surface, and you can study them and take samples like in the Sierra Nevadas in California in the US, where most of the mountain range is going to be granite, and you see half dome here of this amazing natural landscape and features. So you can see that igneous rocks play a huge role in the foundational formation of our crust, our lithosphere, the movement of the plates, volcanic activity, the creation of new rock and new land, and also the destruction of land and going back into magma then to reform into igneous rock again.